In this video, we'll be going over how to use spacecraft CAD models in Cosmographia. The example on the left is using the DAWN CAD model in a sun-synchronous orbit around the Earth, and if anyone knows why the CAD models for the lunar GRAIL spacecraft are toasters, we'd love to know the backstory. As usual, we've added the scene scripts in the GitHub repository in this directory, and we've also added the DAWN and GRAIL CAD models. The geometry parameter in the spacecraft catalog is where we implement CAD models in the Cosmographia. So we do this with the mesh type and the source, and notice that the source is a relative path from where the spacecraft.json file is to the CAD file. And a note on the types of CAD files that Cosmographia accepts. Their documentation says that they only accept .3ds and .cmod, but they also have an example CAD in their resources that is a .obj accompanied by a .mtl. But when we tried using another .obj CAD, Cosmographia gave an error of too many indices, even with a simplified down model. So for that reason, we decided to convert to 3ds and not worry about the .obj files. The mesh rotation parameter is a quaternion that aligns the 3D model with the spacecraft body reference frame. And this quaternion is a SPICE-style quaternion, so the real part is the first number. So as an example, on the left is the DAWN Spacecraft CAD with no rotation quaternion, and the high gain antenna is pointed in the body x-axis direction. And on the right, with this mesh rotation, the high gain antenna is pointed at the body z-axis. So different CAD models in Cosmographia have different rotations in their spacecraft catalog examples, so the correct mesh rotation will depend on your specific CAD model. So there are a few ways to define the spacecraft body frame, but for this example, we're just going to leave it blank, which defaults to the body reference frame aligning with the EME 2000 inertial reference frame, but we'll get to how to define the body reference frame in the spacecraft catalog in the next video. And in the Python script, we set the central object to be the spacecraft itself. We set the initial camera position and orientation with respect to the spacecraft, which is why these numbers are so small since they're in kilometers. And when we use track object Earth, what this is doing is setting the camera frame to be locked with the spacecraft and the Earth. So in that frame, the Earth seems to be stationary, the Earth vector here, and it seems to be that the body is rotating because the body is aligned with the inertial reference frame. So that's it for this video, and in the next one we'll be going over how to point the spacecraft attitude in the spacecraft catalog to useful positions like solar panels pointed towards the sun and instruments pointing nadir to the Earth.